The dust is already rising before anyone on Earth even knows to look. A red column twists across the ground and something inside it starts to snap. Not thunder from a cloud, not rain from a storm, but sharp little cracks from a sky that feels almost empty. A planet people call dead is making its own secret weather right now. If this is the kind of space story that pulls you in fast, subscribe and stay close. This is for people who want the real mystery, not the clean, simple version, because the truth about Mars just got stranger than the headline. For years, Mars looked easy to explain from far away. It was the cold red world, the dry world, the empty world, the place where wind pushed dust and old craters sat in silence. People talked about it like a planet that had already finished all its important work. It felt more like a fossil than a living place. That picture was never fully wrong, but it was never fully right either. Mars is cold, dusty, and harsh, and its atmosphere is very thin compared with Earth's. NASA says it is a dusty, cold desert world with a very thin atmosphere, not a world with deep air and thick weather. But thin is not the same as nothing, and that difference is where this whole mystery begins. When most people hear the word lightning, they picture Earth. They imagine dark clouds, heavy rain, deep thunder, and a bright, jagged flash across a wet sky. That kind of lightning needs thick air, big storms, and a lot of energy built up in the right place. So on a world like Mars, the idea sounds almost impossible at first. That is why this story feels like a contradiction. The kind of place that seems least likely to make lightning has now given us proof of electrical discharge. Not on Jupiter with its huge storms, and not on Earth with its oceans and clouds, but on dusty Mars. The surprise is not just that it happened, but how it happened. To feel how strange this is, think about Mercury for a moment. NASA says Mercury does not really have an atmosphere like Earth does. Instead, it has a thin exosphere, a ghost-like shell made of atoms knocked off the surface by solar wind and small impacts. That is a true near airless world, and it does not have weather like this. Mars is different in a sneaky way. It has enough air to make seasons, winds, dust devils, and giant planet-wide dust storms. NASA says the air is made mostly of carbon dioxide with nitrogen and argon mixed in. It is sparse, weak, and dusty, but it is still active enough to keep changing the planet, and now we know it is active enough to crackle. The heart of the mystery is dust. Mars has dust on its plains, dust on its rocks, dust in its valleys, dust in its sky, and dust moving almost everywhere the wind can reach. Dust gets lifted, dropped, scraped, bounced, spun, and smashed together again and again. Once you understand how much rubbing happens on Mars, the idea of hidden electricity stops sounding so crazy. Scientists had a reason to suspect this long before they could prove it. When tiny grains rub against each other, they can swap electric charge. That process is called the triboelectric effect. But the simple version is easy. It is the same kind of static electricity you feel after walking across a carpet and touching metal. You know that little sting that jumps to your finger. You know the crackle from a sweater or the way hair can stand up on a dry day. Now scale that up from a room in a house to a spinning tower of red dust on another world. That was the old idea about Mars, and for many years it was only an idea. It sounded smart, but proof stayed out of reach. Dust devils became the main suspects. A dust devil is a rotating column of warm rising air that picks up dust from the ground. NASA says they form when air near the surface gets heated by the warmer ground and starts to rise through cooler air above it. As other air rushes in to replace it, the spinning begins, then the dust joins the spin, and the whole thing becomes a moving tower. Mars makes these things all the time. Orbiters have seen them from above, and rovers have seen them cross the landscape like ghosts made of red powder. Some are small and quick, while others stretch tall and cast long moving shadows. They are part of the normal weather of Mars. That is what makes the next part so important. The question was never whether Mars had dust devils, and the question was whether those dusty whirlwinds could build enough charge to make real discharges, not just silent charge stuck inside the dust. Scientists needed evidence that the electricity was jumping, not just gathering. They needed something recorded, measured, and repeated enough to kill the doubt. That is where Perseverance changed the story. Do you still think of Mars as quiet after hearing this setup, or does it already feel more alive than you expected? Tell me in the comments, and if you like space stories that get weirder the deeper they go, hit like and subscribe, because Perseverance did not just look at Mars here, it listened. NASA landed Perseverance in Jezero crater in 2021. Jezero is not just any crater because scientists think it once held a lake and a river delta long ago. That made it one of the best places to search for signs of ancient life and ancient water. The rover arrived to study rocks and history, but Mars handed it a fresh mystery from the present. One of Perseverance's key tools is called SuperCam. SuperCam can study rocks in several ways, and one part of it is a microphone. That microphone was made to hear the laser tool as it zaps rocks, but it can also hear wind, dust, and other sounds in the Martian air. And a lot of people would never guess a microphone might help confirm lightning on another planet. But hearing is sometimes better than seeing. A camera can show a dust devil passing by, but it cannot always reveal what is happening inside the dust. A microphone can catch little bursts, little clicks, little snaps that a picture would miss. And on Mars, those tiny sounds matter because the electrical events are not giant, sky-splitting bolts. They are smaller, faster, and easier to overlook. Scientists knew the microphone might be able to help. They thought it could pick up electromagnetic disturbance, which is basically static interference, and maybe the sound of electrical discharges too. What they did not know was whether those events happened often enough or close enough to the rover. A tool can be perfect and still miss the moment if the moment never comes near it. Mars had to cooperate, and over time it did. As the mission continued, the rover kept collecting audio and other data while dust devils and and storms moved through Jezero, the team began to notice patterns that matched what the old theory predicted. Not one strange sound, not one lucky pass, but a growing set of clues that lined up with dusty weather. Slowly, the maybe started turning into yes. The first major trail of evidence began on the mission's 215th Martian day, or SOL, in 2021. A SOL is just a day on Mars, and a Martian day lasts about 24.6 hours, very close to an Earth day. On that SOL, the rover recorded a dust devil event that carried the kind of sound scientists had hoped for. The signal was not random and not empty, and it sounded like charge becoming action. Then the evidence kept piling up. NASA says SuperCam recorded 55 distinct electrical events over the mission. That number matters because it means the phenomenon was not a one-time fluke. A fluke can fool you once, but 55 events begin to tell a story about a real part of Martian weather. Repetition is what turns a strange idea into a solid finding. 16 of those 55 events were recorded when dust devils passed directly over the rover. That is a huge detail because it ties the electrical signal to a visible weather event. The charge was not floating in from nowhere and not coming from some hidden machine part on the rover. It arrived with the dust devil itself. The suspect was standing right at the scene. 35 other discharges were linked to convective fronts during regional dust storms. A convective front is a rough moving boundary where warm and cool air interact in a churning way that lifts dust hard and fast. In plain words, Mars was not only making sparks in little spinning towers, it was also making them in broader, dusty weather. When the atmosphere turned rough and violent, that widened the whole picture. This is the first big turn in the story. Scientists expected dust on Mars to become charged because rubbing grains almost had to do that. What they were not sure about was whether the charge would cross the line into real discharge often enough to detect clearly. What NASA found was that the crossing does happen. The hidden step from dusty rubbing to actual spark is real. And this is where the headline needs a careful correction. NASA did not confirm giant cloud-to-ground lightning on a planet with literally no atmosphere. It confirmed electrical discharges and their shock waves in the very thin atmosphere of Mars. That sounds smaller, but it is actually more unsettling because it means a world many people treat as almost empty is still electrically active. The best single moment came much later in the mission. NASA says that on October 12, 2024, a dust devil passed over Perseverance and the SuperCam microphone captured 3 clear crackles. 3 crackles does not sound like much until you remember where they happened. They happened on Mars, inside a moving dust devil in a place we once thought of as nearly silent. That is not a small fact. Those crackles were not floating alone in the recording. NASA said they could be heard between the sounds of the dust devil's front wall and trailing wall, so the rover did not just hear a snap in empty air. It heard the sound inside the body of the dust devil as the storm moved over it. That gives the whole event shape, timing, and context. The spark belonged to the weather system. Ralph Lorenz, a scientist on the Perseverance team from the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, helped explain what made the recording so good. He said some events clearly let you hear the snap of the spark. In the SOL 215 Dust Devil recording, you can hear the electrical sound in the wall of the Dust Devil moving over the rover. In the SOL 1296 event, you hear that plus some of the particles hitting the microphone. That last detail is easy to miss, but it is powerful. The microphone was not hearing a distant guess. It was sitting inside the moving dust and getting struck by grains while the electrical event took place. That is almost like being inside a storm with your eyes closed and still knowing exactly where the energy is. The rover was not just watching Mars for a moment. It was inside the problem. And there was another sign too. NASA said the rover recorded mini sonic booms along with the discharges. A sonic boom is just a shock wave, a quick pressure pulse that moves through the air after a sudden event. Most people think of jets when they hear that phrase, but here it was tied to little electrical bursts in Martian dust. And that tells us the discharge was disturbing the thin air in a measurable way. And now comes the part that feels backward until you think it through. On Earth, you might assume thicker air would make sparks easier. But NASA says that on Mars, the thin atmosphere makes these discharges more likely near the surface. The amount of charge needed to generate sparks is much lower there than in Earth's near-surface atmosphere. So the weak air of Mars actually lowers the bar. That flips our normal thinking. We expect thick clouds and heavy air to help electricity because that is the world we know. Mars teaches the opposite lesson for this kind of event. When enough charge builds in blowing dust, the thin air can give way more easily. A smaller push can become a real spark. The world that looks too empty becomes easier to break electrically. Baptista Chidi, a member of the Perseverance science team, said charging of sand and snow particles is well known on Earth, especially in deserts. But he also said that on Earth it rarely turns into actual electrical discharge. On Mars, the thin atmosphere changes the rule. The charge needed is lower, so sparks are far more likely. And that one shift turns a quiet dust devil into an electrical machine. Did you expect thin air to make sparks easier instead of harder? If that detail just flipped the whole story for you, leave a comment saying what surprised you most so far. And subscribe for more real science that sounds fake until the numbers show up, because the numbers on Mars keep coming. Another surprise showed up when researchers looked at timing. You might expect the discharges to grow strongest during the dustiest seasons. When more dust is spread through the atmosphere across the planet, that would seem simple and clean. More dust should mean more rubbing, and more rubbing should mean more charge. But the data refused to stay that simple. NASA said the electrical discharges did not seem to increase during seasons when dust storms make atmospheric dust more common across Mars. That result matters a lot. It suggests the buildup is tied more closely to localized, turbulent lifting of dust and sand rather than dust density alone. In plain words, what matters most is not how dusty the whole sky is, it is how violently the dust is being thrown around in one place. That changes the way scientists think about Martian weather. A broad, dusty season might make the sky look dramatic, but a local patch of rough rising air may be more important for creating sparks. The danger is not just the amount of dust, it is the kind of motion acting on that dust. Mars can look calm from a distance and still hide intense activity in a small moving zone. Dust devils now seem even more important because of that. They are not just visual signs that air is moving, they may be the best small laboratories on Mars for turning friction into electricity and electricity into chemistry. Each spinning column becomes a test chamber built by nature, and because Mars makes them often, the planet may be running this test over and over all the time. That makes the discovery feel less like an event and more like a process. NASA explained how a dust devil forms in simple steps. The sun warms the ground warms the air right above it, and that warmer air starts to rise. Cooler air moves in along the surface to replace it. And as that air rushes in, it begins to rotate. Then the rotating air pulls dust with it, and the column is born. NASA used a great image for that motion. As air moves inward and then rises into the spinning column, it speeds up like a figure skater pulling in their arms. That means the dust devil can tighten and strengthen quickly. Now picture thousands or millions of grains smashing, bouncing, and scraping inside that fast-moving spin. The whole thing becomes a giant rubbing machine. Static is not just possible there. It feels almost unavoidable. And this is not an old finished chapter. In January 2025, while exploring the rim of Jezero crater, Perseverance captured new images of multiple dust devils moving across Mars. So these events are not something that happened once and then disappeared. The weather system that makes them is active right now. The same kind of physics that caused the crackles the rover recorded is still at work. Mars is still running the experiment. To understand why that matters, it helps to remember what Mars is like overall. NASA says Mars is about half the size of Earth, with a radius of 2,106 miles or 3,390 kilometers. It sits about 142 million miles from the Sun on average, which is about 228 million kilometers. Sunlight takes about 13 minutes to get there. It is far, cold, and yet still close enough to keep teaching us new things. Its day is almost like ours. Mars rotates once every 24.6 hours, which is why scientists use the word sol for a Martian day. Its year is much longer, though, at 687 Earth days. Its seasons exist because its axis is tilted, like Earth's, but those seasons are stretched out because the trip around the sun is longer. So Mars is not a frozen, still picture. It has rhythms and cycles. NASA also says Mars can be as warm as 70 degrees Fahrenheit or 20 degrees Celsius, and as cold as about minus 225 degrees Fahrenheit or minus 153 degrees Celsius. That range is wild. At the equator at noon, NASA says it could feel like spring at your feet and winter at your head. That image says a lot. Mars may seem simple, but its environment is full of sharp contrasts. The sky would not look blue there. NASA says it would look hazy and red because of suspended dust. That dust does more than color the view. It changes weather, moves across regions, and now seems able to trigger electrical discharge and chemical reactions. So the red sky is not just background beauty, it is part of the machine. Mars also had a very different past. NASA says missions have found strong evidence that Mars was much wetter and warmer billions of years ago with a thicker atmosphere. There were river valleys, deltas, lake beds, and minerals that could only have formed with liquid water. Jezero crater itself was chosen because it likely once held a lake. And that means today's sparks are happening on the ruins of an older world. And that older world matters because one of the biggest questions in space science is whether Mars could ever have supported life. NASA says scientists do not expect to find living things thriving there today. Instead, they look for signs of life that may have existed long ago when the planet was warmer and covered with water. That search depends on chemistry, and this is where the sparks become more than a cool sound effect. NASA says the presence of these discharges means the Martian atmosphere can become charged enough to activate chemical reactions. A chemical reaction is just a change where atoms rearrange into something new, and these reactions can create highly oxidizing compounds, which are substances that aggressively break down other molecules. If that sounds technical, think of them as chemical attackers. They do not leave fragile material alone for long. Two of the most important names here are chlorates and perchlorates. You do not need to love the names to understand the problem. They are strong compounds that can destroy organic molecules on the surface. Organic molecules are the kinds of carbon-based molecules tied to life and to signs that life may once have existed, so every new spark may be helping build a harsher chemical world. This is one of the darkest twists in the whole story. Scientists go to Mars hoping to find traces of ancient life, but the same dust that drifts across the planet may be helping create chemicals that erase part of that record. Mars may not just be hiding clues, it may be wearing them down, breaking them apart, and scrubbing the surface over long stretches of time. That makes the search harder and more urgent at the same time. The discovery may also help explain another Mars puzzle. Scientists have seen signs of methane on Mars before. Methane matters because on Earth it can come from both life and non-living processes. The strange part is that Martian methane seems able to vanish faster than many people expected. Something appears to be breaking it down quickly. The new electrical chemistry might be part of the answer. If dust-driven discharges are helping create very reactive compounds, those compounds could attack methane and other molecules in the atmosphere. Then that would give Mars a quiet cleanup system powered by friction, charge, and dust. No giant storm clouds, no dramatic lightning bolts across the sky, just countless tiny electrical events doing chemical work. That is a very Martian kind of threat, subtle, dry, and easy to miss until the evidence stacks up. What sounds more shocking to you right now, that Mars can spark, or that those sparks may be helping erase clues of ancient life? Drop your answer below, and if you want more stories where one hidden process changes everything, subscribe before the next reveal, because the next question is about us. NASA also said the discovery matters for engineering. Confirming electrostatic discharges helps the agency understand possible risks to the electronics on present and future Mars missions. So far, no major harmful effects from this kind of discharge have been reported over decades of Mars surface operations. That is probably a sign that spacecraft grounding has been done very carefully. Good design has kept the danger under control. Grounding means giving electric charge a safe path so it does not build where it can damage equipment. That works well, but only if engineers know the environment they are designing for. A world with dust and wind is one thing. A world with dust, wind, and repeated static discharges is another. The new finding tells future mission planners that Mars should be treated as an electrical environment too. And that changes the checklist. Think about the tools a rover carries. Cameras, sensors, microphones, computers, cables, power systems, moving parts, and delicate instruments all have to survive in extreme cold and heavy dust. Now add the possibility of local static discharges during dust devils and storm fronts. Even if the risk stays low, it is still a real factor. And when a mission costs billions and takes years, even a small risk deserves attention. Space is not forgiving. Then push the picture forward to human missions. If astronauts one day live and work on Mars, they will carry tools, wear suits, drive vehicles, and move through dusty air almost every day. Dust will cling to surfaces, scrape against fabrics, and coat equipment. If that dust also helps generate charge, then static becomes part of daily life. A spark in the wrong place can be more than annoying. It can threaten systems people depend on to stay alive. Mars dust is already known as a problem. It is fine, clingy, and able to get into cracks and joints. It can cover solar panels and change how machines work. Now imagine that same dust as part of a moving electrical system. It stops being just a cleaning problem and starts becoming a safety problem. The planet would not only be dirty, it would be quietly active against your technology. That is why this story feels personal, even though it happened far away. Every discovery on Mars changes how we imagine going there. People often dream about rockets, habitats, and footprints in red soil. They do not always picture little invisible snaps in dust devils or chemical damage spread by static weather. But those small realities are the ones that decide whether a place is truly livable. The devil is often in the details, and on Mars it may be in the dust devil. The discovery also changes the personality of Mars. For a long time, people talked about the planet like an old dead desert. Now it feels more restless. Its air is thin but not passive. Its dust is fine but not harmless. Its weather may not roar like Earth's weather, but it can still bite, react, and reshape the planet in secret ways. There's another wider layer too. NASA says Mars has no global magnetic field today, though parts of its crust still carry signs of an ancient one. That means the planet is exposed to the solar wind in ways Earth is not. NASA's ESCAPADE mission will study Mars's real-time response to the solar wind to better understand its climate history. That is not the same as a dust devil spark near the ground, but it reminds us that Mars is interacting with space and with its own thin air at many levels. Mercury helps us see the contrast more clearly. NASA says Mercury has no real atmosphere, only an exosphere made mostly of atoms blasted off the surface by solar wind and meteoroids. That is a truly near-airless environment. Mercury can have magnetic interactions and extreme temperatures, but it does not have dust devils built from rising warm air like Mars does. So if you want weather-made sparks, Mars is the more surprising stage. And that is also why the headline feels so strong. People hear planet with no atmosphere and think of a world where weather should be impossible. Mars is close enough to that idea to make the claim feel shocking, even though the better wording is a planet with a very thin atmosphere. And maybe that is the deeper lesson. Sometimes one small missing word hides the whole truth. Thin does not mean weak in every way. Mars's atmosphere is thin, but it still shapes temperature, lifts dust, drives storms, colors the sky red, and now appears able to help sparks jump through moving columns of sand. The world is not empty just because it is spare. Sometimes a small amount of the right thing in the right place can change everything. Mars may be proving that with every crackle. This is one reason science can feel so humbling. It is not always the big obvious force that surprises us. Sometimes it is a tiny detail in a rough environment that breaks the old model. The weak atmosphere turns out to make certain sparks easier. A little microphone turns out to be the tool that catches them. A dust devil turns out to be both weather and chemistry in motion. And notice how the proof arrived, not from one dramatic photograph that everyone could instantly understand, not from a huge explosion in the sky. That came from careful listening, repeated events, cross-checking patterns, and patient study over time. That is how many real discoveries work. They do not burst through the door. They slowly corner the truth until it has nowhere left to hide. NASA said the research was published on November 26th in the journal Nature. That matters because it shows this was not just a loose claim in a press release. The result was studied, written up, and put through the kind of review serious science expects. The headline sounds wild, but the path to it was cautious. That balance is important. Amazing claims mean more when the method is careful. And the method here was strong because it mixed different kinds of evidence. Audio recordings, electromagnetic disturbances, timing with dust devils, timing with storm fronts, and repeated events all pointed in the same direction. Any one piece by itself might leave room for doubt. Together they create a much firmer picture. This is not belief built on mood, it is a case built on matching signals. Jezero Crater adds one more layer of poetry to the story. This is a place chosen because it may hold clues to an ancient lake and ancient life. Now, in that same place, the rover has found evidence that present-day Mars may also be making chemicals that destroy life-related molecules. The past and present are colliding there. One side offers memories of water. The other side offers active processes that may erase those memories. That is almost painfully perfect. We send a rover to a place that may preserve the record of ancient habitability. Then the rover reveals a mechanism that may help break down that very record. Mars is giving and taking at the same time. It shows us where to search, then reminds us how much may already be lost. No wonder the planet keeps holding us. And still, the story is not hopeless. Knowing a process exists is power. If electrical discharges help create destructive chemistry, then scientists can design better ways to search for surviving clues. They can choose better depths, better sample sites, and better tools. They can ask new questions that were impossible before. Discovery does not only close doors, it opens smarter ones. Future missions can now look for regions where this chemistry may be weaker or stronger. They can test whether certain soils preserve organic material better than others. They can listen for more discharges, measure charge more directly, and map when the events happen most often. The proof from Perseverance is just the start. Now that the planet has confessed, people can ask sharper questions. Mars has changed from suspect to witness. How many hidden processes do you think are still waiting on Mars for the right tool to catch them? Write your guess below, and if you want to be here when the next quiet secret turns loud, subscribe and turn on the bell, because this world is not done surprising us. There's also something beautiful about the size of the event. On Earth, we often only respect the dramatic. Big storms, huge flashes, loud thunder, giant plumes, and obvious destruction get our attention. Mars reminds us that small events can matter just as much. 3 crackles and a dust devil can change how we think about chemistry, life searches, robots, and future astronauts. A tiny sound can redraw a planet. That idea reaches beyond Mars. Other worlds may also hide important truths in weak signals. A soft vibration, a faint gas change, a brief temperature jump, or a strange repeating click may hold more meaning than the spectacular image everyone shares first. The universe does not owe us loud answers. Sometimes it whispers, and if we are patient enough to listen, the whisper can be bigger than thunder. The SuperCam microphone deserves more respect because of that. People tend to admire the big cameras and dramatic photos, and that makes sense because those images are powerful. But here, a microphone helped prove a theory that had lingered for years. It heard what our eyes would likely miss. On a planet millions of miles away, sound became evidence. And that feels almost magical, even though it is pure engineering. Mars also keeps teaching the same hard lesson. Never confuse old with inactive. A cratered desert can still have weather. A thin sky can still carry danger. A dry world can still run chemistry hard enough to rewrite its own surface. And a place that looks empty can still be full of hidden processes. And that is why every fresh measurement matters. If we zoom out even more, the story becomes about curiosity itself. Humans looked at Mars for centuries and saw a red point of light. Then we saw canals that were not there, then deserts, then dry riverbeds, then rovers crossing cracked ground. Now we are hearing electrical crackles in the dust. Each step makes the planet less like a symbol and more like a real place. That is the gift of science. A real place is harder to simplify. Mars is no longer just the red planet. It is a world with ancient floods and present dust devils. It has giant volcanoes, a canyon system bigger than anything on Earth, frozen water, thin air, and active chemistry. It has a past that invites hope and a present that warns caution. And now it has confirmed sparks in its own moving dust. That is a richer and stranger world. NASA says Valles Marineris stretches about 2,400 miles across Mars. It says Olympus Mons rises more than 25 miles high. Those giant numbers make Mars feel huge and dramatic, but the new lightning story comes from something much smaller, a burst of static, a grain-filled vortex, a microphone click. That contrast is part of what makes the discovery unforgettable. The giant world changed because of tiny sounds. There is also a very human feeling inside this. We want new worlds to be simple enough to dream about. We like posters of bases on Mars, clean domes, brave explorers, and red sunsets. And then real science comes along and adds dust that may damage systems, chemistry that may erase clues, and weather that sparks where it should not. At first that can feel disappointing, but really it makes the dream more honest. An honest dream is stronger than a fake easy one. If people ever live on Mars, it will not be because the planet was gentle, it will be because we learned its tricks well enough to survive them. Every discovery like this is a step toward that truth. It turns fantasy into planning. It changes adventure into preparation. And preparation is what actually gets humans farther. The same goes for the search for life. If Mars has been building harsh oxidizing compounds through electrical discharge, then life clues may be rarer near the surface than we hoped. That does not mean the search is pointless. It means we have to search smarter. Maybe deeper layers matter more. Maybe sheltered rocks matter more. Maybe certain times and places matter more. This is the repeating pattern that keeps making the story better. Scientists expected charge in Martian dust. What they found was real discharge. They expected dust amount alone to matter most. What they found was that local turbulent lifting mattered more. They expected weather to be part of the background. What they found was weather acting like a hidden chemical engine. And then the pattern rose again. People expected the big danger on Mars to come from cold, radiation, and lack of oxygen. Those are still real dangers. But now we add static discharge and chemistry pushed by dust to the list. Mars keeps showing that the threats are not always where first instincts place them. The obvious problems were only the beginning, and the story is still happening now. Not long ago in some closed chapter, dust devils still spin over Jezero, the same thin air still moves over rusted ground, the same fine particles still rub against one another. Somewhere on Mars, as you hear these words, another column may be lifting and another charge may be building. That is what makes the discovery feel alive. It is almost eerie to picture a world that from Earth can look like a calm red dot is actually full of motion at the small scale. Not the kind you would hear from space and not the kind you would guess from a still image. But there is warmth rising from the ground, wind bending around rocks, dust climbing in spirals, and energy jumping in little bites. That Mars is not loud from afar, it is intimate up close, and that may be the real reason people cannot look away from it. Mars is close enough to imagine and strange enough to resist being fully known. Every time we think we have reduced it to a single idea, it pushes back. Dead planet, no. Wet past, yes. Thin air, yes. Simple weather, no. Silent dust, no. No atmosphere, lightning almost, but not in the way anyone expected. So what did NASA really confirm? It confirmed that Perseverance recorded electrical discharges, sparks, and mini sonic booms. In dust devils and dusty storm fronts on Mars, it confirmed 55 distinct electrical events over the mission, including 16 during dust devil passes and 35 linked to convective fronts in regional dust storms. It confirmed that thin Martian air makes these discharges easier than many people would guess. And it confirmed that this changes how we think about Mars. That change reaches from chemistry to habitability, from engineering to exploration, from ancient life clues to future human safety. A crackle in a dust devil sounds small, but small things can force big revisions. A few sharp sounds in the Martian air may now shape where we search, how we build, and what risks we respect. And that is how science moves, not always with a bang, but often with a better question. If you had to guess, do these sparks make Mars feel more exciting to you or more dangerous? Tell me that in the comments, and if you want more deep space mysteries told with the real details left in like this, and subscribe before you go, because one day these small clues may decide where humans dare to stand. And maybe that is the final emotional twist. We look to Mars because we want to know whether life ever rose there, whether humans can go there, and whether another world can teach us something about our own. The answer keeps coming back as yes, but never in the easy form. Mars teaches through resistance. It teaches through dust, cold, loss, and now electricity. It makes us earn every inch of understanding. That is why the little crackles matter so much. They are proof that the red planet is still active in ways we did not fully expect. They tell us that weather on Mars is not just something you see. It is something that can charge, strike, react, and alter. And they remind us that the universe often hides its biggest truths inside the smallest sounds. All we can do is keep listening. If this story changed how you see Mars, subscribe and turn on notifications so you do not miss the next one. Leave a comment telling me whether you think these sparks are a warning sign, a clue about ancient life, or both. Share this with someone who still thinks Mars is only a quiet red desert, and thank you for watching.